into today is about a hierarchical clustering, which is the second clustering algorithms I want to introduce to you guys. In our previous class, we talked about a k-means clustering and we had a great discussion. So in this clustering algorithm, it has a very different perspective of clustering. So what is the hierarchical clustering and what are the advantages as well as the disadvantages are all going to be discussed in this class. Hierarchical clustering is a method of cluster analysis which seeks to build the hierarchy of the clusters. So there are two major ways of doing so. One is called bottom-up approach, which is agglomerative. The other one is divisive, which is the top-down approach. This class we will have a lot of discussions about the bottom-up approach, and we will also talk about how is the top-down, which is a divisive clustering algorithm going to be looks like. So let's start with the bottom-up, which is a agglomerative approach. What this clustering algorithm try to do is super simple. And to the best part of this one is that it almost has no parameters. Unlike k-means clustering, you need to decide the number of the k, you need to decide how do you store the random cluster central locations. For hierarchical clustering, it's super simple. Saying that we look into a two-dimensional space like this one, and we have 8 different nodes. What hierarchical clustering trying to do is that, first of all, it try to look into the mutual distance of them all, and then find the 2 closest points, and then they group them together. So x7 and x.6 and 0.7 are going to be grouped together as the first merging points since they are closest to each other. And then we will try to look into the next closest point. So in here, we will see that the node 2 and 3 are probably the next 2 closest points. So we try to merge them together. As this one, you can see while we try to merge them together, we're going to put a line according to their distance to merge them together. So 6 and 7 are going to be grouped together. Next one is 2 and 3. And you can see that the bar height of the 2 and 3 is a little bit higher than 6 and 7 because it's corresponding to the distance of the point. And therefore, you can see the next 2 points are going to be 4 and 5 as try to be grouped together and form another cluster. Now, once we see 6 and 7 are grouped together, 4 and 5 are grouped together, you will also see that the 4, 5, and 6, 7 are going to be grouped together in the next step. And we will be able to keep doing this until everything has been grouped into a big cluster. So this is the basic idea of the agglomerative hierarchical clustering. If we try to dive into the clustering concepts, you will be able to see this. While we have 8 different points and we look for the 2 closest points, we understand that 6 and 7 are going to be grouped together. So we group them together and we can use the centroid again to represent the center of the cluster. In other words, if we come back over here, you can see that the 6 and 7, once they have been merged together, the middle point is going to represent this cluster and then use that point to calculate the distances with all other points. And therefore, you can see the next step is going to group 2 and 3 together. And then we're going to group 4 and 5 together. While at this point, we actually have 3 clusters. In the idea of the cluster, it depends on how we define it. If we, in the beginning, if we define every single point as 1 cluster, then in this slide, we have 1, 2, 3, 4, 5, 6, and 7 cluster. Of course, if you try to look into the perspective, only multiple points can look as a cluster. Then in this case, we only have 6 and 7, 1 cluster, because all other points are just a single point. So it depends on how you're going to see it. And in this case, if we are looking into the cluster considered as multiple points as a cluster, then we have 2 clusters here, and we have 3 clusters here now. And while we combine 4, 5, one cluster with another 6, 7 cluster, we actually form a bigger cluster in this case, and therefore we have this one cluster as 4 points with the other cluster as 2 points. And of course, x1 and xa, if we don't continue, we are actually looking into 2 outliers kind of idea over there. So that if we keep going on, we will merge x1 with the cluster of x2 and x3, and then we will merge the other case of that. And finally, we will be able to group everything together, and that is the end of the hierarchical clustering. You can see this is actually pretty straightforward and pretty easy concept. However, there is one parameter in the end that you need to make the decision. That is, where would you cut your hierarchical clustering? Because if you don't cut it, right now everything is one gigantic cluster. And therefore, if you try to cut at this line, so you can see that if I'm going to cut at this line, we will create 2 clusters. One cluster is composed of 1, 2, and 3. The other cluster is composed of 4, 5, 6, 7, and 8. So if we cut in this line, we will end up with 2 clusters. If we try to cut in this line, you can see that that is the line that we will form one cluster and another cluster with 4, 5, 6, and 7, while x1 and x8 are being left out, which we still get 2 clusters with 2 outliers. Again, depends on how you want to see it. You, at that stage, you can still think x1 as one cluster, 2, 3 is another, 4, 5, 7 is another, and x8 is another cluster. So this can have a lot of flexibilities here. However, where to cut the line is always the hard part about the hierarchical clustering. So compared with k-means clustering, it is hard to start the clustering. For hierarchical clustering, it is in the end of the clustering, you need to decide the parameter to cut the dendrogram. That's what we talk about, the tree structures that we have here to form really clusters. And therefore, there is actually no perfect clustering algorithms after all. In our Thursday class, I will talk about a clustering that kind of combines the hierarchical clustering as well as the k-means clustering, merging into one kind of special clustering called hybrid hierarchical k-means clustering. I'm actually the one who develops that. So we want to see how can we merge the 2 clustering algorithms together to avoid the parameter setup. However, come back to this class, we want to focus on the hierarchical clustering. So that you can see in our next slide, this is a real example that try to use the hierarchical clustering to build up on a microarray dataset. So when we do that, you can see the dendrogram, the tree structure on the left side, which cluster the genes. And you can see that is exactly the tree structures that we have seen. On the other side, it can also cluster the samples or the experimental setups results, and we can also form another dendrogram over here to to get you a better understanding of what the microarray data try to do. So this is actually a real experiment. The paper I want you guys to read after today's class is also something related to the microarray analysis. So the next thing I want you guys to do is bring out a pen and paper. So this is the sample, the example that we did in k-means clustering. In our k-means clustering class, we talk about when I want you guys to group this data. There are actually like 15 data over there. into 3 clusters and with initial centroid of 3, 16, and 25 in our previous class. So now, what I want you guys to do is use the same data set and then bring out your pen and paper. Try to work on this data set and then think first of all, what is the hierarchical clustering result will looks like using your human mind. And after you do that, I also want you to think, how does computer, when you try to write a program, how does computer try to create the hierarchical clustering based on this data set? So this is my first part of the video. I will stop over here. I want you guys to think about, again, what is the hierarchical clustering result may looks like based on this data set. Bring out a pen and paper and then try to work on this one. And then I want you to think, how would you write a program? And how does the program to process this data set to form a hierarchical clustering? So that's the first part of the video. I will see you guys in the next part of the video.